In this video, we are going to interact with third year student of Rias. For the topic is how about the simulation will be working or will be analyzed from dimensional flows. Recently, we completed his internship in BSSC Trivandrum with the ISRO scientist. So basically, he worked about pressure regulator concept and how it will be modified in the flow direction. Riaz, first you have to share your topic and what will be you made in that you were written in that ISRO.
So, hi everyone. My topic was about one-dimensional simulation on pressure regulator. So we used to have the pressure regulator in the rocket systems where we have got the propellants such as namely fuel and oxidizer, right? So both these fuel and oxidizer, due to the time seconds at t, it will reduce. When you just drain out the bottle completely which is filled of water, it will be completely depleted, right? At t seconds. Same way, the oxidizer and the fuel will be depleted after some time. So, if both the propellant, the fuel and the oxidizer gets depleted, the structural integrity of both these tanks will be it will be reduced. Okay. So, in order to maintain the structural integrity, we will be injecting certain gases such as hydrogen or nitrogen into these separate tanks. So these gases will be filling out the rested out of the area, like in the entire complete tank, the rested depleted region. So those area, these gases will be filling out, and so in such a way that the integrity will be
okay, fine. First, what is your role in that intern? Okay. You have to analyze, or you have to any documentation, or you have to working with any chemical reaction.
No.
Or what is your contribution in that your role in intern period?
So my contribution was mainly just a part. Okay. So I was made to make a simulation. So this is a one-dimensional simulation software, animation. So in that we'll be having a complete sketch diagram. So in a certain sketch we'll be having a lot of parts such as poppet, gas chamber, inlet, outlet, and many moving parts. Okay, so mass friction. So we'll be having a lot of small components. So we'll be connecting every component in a certain sketch, and after we'll be selecting every single component and we will be giving certain values in it. So after giving the values, it may run or it may not run, because we really from the scratch we really don't know what's the minimum and the maximum level of the input which has to be given properly. So that has to be properly be analyzed, or the data has to be given from the department, because for a certain element we exactly don't know how much the value has to be inputted, right? So if the values are properly be given, the simulation will be done. If not, the values has to be changed, and so we'll be getting an outlet. So the outlet and the inlet has to be something like, we'll be having a certain graph. So
what is the name of the graph? You have plot a graph from the software. You have maintained any app or any software for making the graph.
EC plot.
EC plot.
EC plot is a small EC software. And so in that we'll be importing the file from the animation, and then we'll be having time and the pressure, inlet pressure. Okay, so we'll be having two graphs. So one for the inlet and with respect to time, another will be like outlet with respect to time. So both has to be like regardless of the varying input pressure, we need constant output pressure. So that's
from the graph, what the time will be extended? Whether it's for input pressure or output pressure, like results.
Okay, so 160 seconds is what I have given, and for that we, the simulation we will be having some parts, like, so we will be dividing it so certain many parts. So I have had some 160 seconds as time period, and the maximum pressure is like something like 330 bar.
Okay. Okay. Thank you.